Hello Math 3 students, this is Mr. Lal and I'm just going to do some tutorial videos on our practice test. So watch these videos, go at your own pace, and you can learn how to do them. Let's get started. Now, if we actually look at the first problem, if I adjust my screen here, we have, as shown in the diagram below, the diagonals of the parallelogram QRST intersect at point E if QE is x squared plus 6x, SE is equal to 2x plus 32, and TE is equal to 3x minus 2. Determine the length of TR algebraically. So if we're going to do this problem right, first we need to copy the relevant aspects of the problem. So this is number 1 for our study guide. And let's draw our parallelogram. So obviously this is an approximation for the drawing, but this is going to be, have two diagonals, and so this diagonal is going to be 3x minus 2. This diagonal right here, the one that my cursor is going wrong, is going to be 2x plus 32, and then this diagonal is going to be x squared plus 6x. And let's label our parallelogram, because this is point E, this is point T, this is point S, this is point Q, and this is point R. Now, we need to, what's the objective? That we need to find TR algebraically. So we need to find TR. Okay, so how are we going to do that? Well, first of all, one of the primary things about parallelograms is diagonals bisect each other. So this diagonal right here, that might see my cursor going over, that bisects the diagonal QS, which means QE is equal to ES, and we can write that. QE is equal to ES because diagonals bisect each other. So therefore, QE is x squared plus 6x, and EX is 2x plus 32. So x squared plus 6x is equal to 2x plus 32. And what we're going to do is we're going to put this into a quadratic equation equal to 0 so we can factor it. So you subtract 2x from each side, you subtract 32. So we subtract 2x and we subtract 32. And x squared stays the same. 6x minus 2x is 4x. And then we have our negative 32, and it's equal to 0. Now, when we factor this quadratic, we need to come up with two numbers that multiply to negative 32 and add to 4. And so pause this video if you want to go through the steps, but essentially those numbers are going to be they're going to be 8 and negative 4. So that's going to be x plus 8 and x minus 4. 8 minus 4 equals 4, and 8 times negative 4 is equal to negative 32. So this is a review on factoring, so I'd suggest going to Khan Academy for factoring review if this step is a little bit hard for you. Now, this is equal to 0, so we need to find the value of our x's. So we have x minus 4 equals 0, and x plus 8 is equal to 0. So to solve for x, we just get x by itself, so add 4 to each side. We have x is equal to 4, and x is equal to negative 8. Now we get two answers, but x can only be one of them. And x is actually going to be equal to 4, and x cannot be equal to negative 8, because distance cannot be negative. We're looking at the distance of a side of a parallelogram, and distance cannot be negative. Alright, let's continue on. So x is equal to 4. So we need to find TR. And we know that diagonals bisect each other, so that means that this side, TE, is going to be equal to, this side is equal to ER. So if these two are the same, that also means that 2 times TE is going to be equal to TR, which is what we're trying to find, because TE plus ER equals TR. So if TE is equal to ER, then 2 times TE is equal to TR. So once again, pause the video, look at the logic, look back at your parallelograms notes if you need to understand why TE times 2 is equal to TR. But we need to find TR, that's how we find our answer. So 2 times TE is equal to TR. So TE is 3x minus 2. It's written right there. So 2 times 3x minus 2 is equal to TR. We distribute that 2. So 2 times 3x is 6x. 2 times negative 2 is negative 4. And negative 4 is going to be equal, so 6x minus 4 is equal to TR. And we know that x is 4. So we're going to plug in the 4 into 6x. So we're going to plug in that 4 here. 6 times 4 minus 4 equals TR. 6 times 4 is 24. So 24 minus 4 is equal to TR. And 24 minus 4 is 20. So 20 is equal to TR, and 20 is our answer. Alright, I'm going to end the recording and do another one for problem number 2. My apologies. Problem number 2 in our Common Assessment 1 study guide for Math 3. In the diagram, a rectangular container with the dimensions 10 by 15 by 20 inches is to be filled with water using a conical cup whose diameter is 3.5 inches and whose height is 4 inches. What is the maximum number of full cups of water that can be placed into the container without the water overflowing the container? So, if you really think about this problem, the number of cups that you can put into the container without overflowing it is going to be the volume of the big container, and you're going to have the volume of the cup. And what you're going to need to have is you're going to have to divide the two. All right. Sorry, looking at some of my notes here. So you're going to have to divide the volume of the big container by the volume of the cup to figure out how many cups will fit into the container. So let's get working on the problem. You have your rectangular prism, and I'm going to make a very shoddy drawing of a rectangular prism, which is going to be 20 by 10 by 15. And so the volume of a rectangular prism is going to be our length times our width times our height, or the area of the base times the height, doesn't matter how you do it. So the volume is going to be equal to 15 times 10 times 20. And that value, check with your calculator, it's going to be equal to 3,000. Now, we're going to have to find the volume of the cone. So we have our cone here. We have a 3.5 inch diameter. So our diameter is 3.5 inches, which means that our radius is going to be half of that. So our radius, which is half of that, that's going to be 1.75. So now we look at the base, now we draw the rest of the cone. So sorry, poorly drawn cone. And the height of the cone is going to be 4 inches. This is all from the problem. So the volume of a cone is going to be equal to 1/3 the area of the base, which is a circle, times the height. And because the area of if the area of the base is a circle, that means you can also write that as 1/3 pi r squared times height. So our radius is 1.75 and our height is 4. To find the volume of the cone, we do 1/3 times pi times, and radius is 1.75 squared, and our height is 4. So let's bring up our calculator here. Check this out, and we can do 1/3 times pi times r squared. So our radius is 1.75, so 1.75 squared times our height, which is going to be 4 inches. And that gets us 12.828, let's round it up to 12.83. So our volume of the cone here is going to be equal to 12.83. And you think about it, this is the amount of times you need to fill up the cone to fill up the rectangular prism. So our answer is going to be equal to the volume of the prism over the volume of the cone. So our answer is going to be equal to the volume of the prism, which is 3,000, and this is inches cubed. By the way, you should always put your units for your volume, divided by 12.83 inches cubed. So that's going to be equal to, well, let's use your calculator to prove it. 3,000 divided by 12.83. That's going to be 233.826. But if you look at the problem, it says, what is the maximum number of full cups of water? So we need to have a whole number, so it's not 233.826. It's just equal to 233 cups of water. Let's make that full cups of water. Alright, so that's problem number 2. I think I might start doing multiple questions per video. So let's erase that and go on to the next one, as said in the song by Jay-Z. Number 3. Use the list of vocabulary definitions to match the correct definition for circumcenter, incenter, centroid, and orthocenter. So for this one, this is not really a math problem, it's just memorizing the correct answers. So incenter, that's going to be the intersection of the angle bisectors. Yes, angle bisectors of the triangle. Of our triangle. The circumcenter, and I'm sorry, I should have done this in order. So circumcenter is going to be the intersection, so I'm copying everything above, of the perpendicular bisectors. So perpendicular bisectors of the triangle. The centroid is going to be the intersection of the medians of the triangle. So we have the medians of the triangle. And then the orthocenter is the intersection of the altitudes. So orthocenter is the intersection of the altitudes. So this is just something you got to memorize. So obviously, circumcenter is A, incenter is B, centroid is D, and orthocenter is F, and everything else is not even the center of a triangle, so we can eliminate that immediately. So that's vocabulary to memorize. That is a vocabulary question. Make sure you know it before the test. Moving on to question 4. Let's do this. Given a cylinder with a radius of 6 inches and a height of 13 inches, find the area of a cross-section that is parallel to the base, and then find the area of a cross-section that is perpendicular to the base. So let's start off with 4A. So 4A, we have our cylinder. We have a radius of 6 inches for the base. And we have a height of 13 inches. And for a cross section is really when you have you have a plane that goes through. I'm not drawing it super well, but it goes through the cylinder, and you look at what the two-dimensional shape is when the plane is created. And here you can actually, if I draw it, you might be able to see it. The shape is a circle, and the circle has coordinates identical to the base. So it's parallel to the base. The shape is a circle. That's going to be equivalent to the base of the cylinder. So the area of a circle is going to be equal to pi r squared. So the area of a circle, pi r squared, so the radius is 6. So the area of that circle is going to be equal to pi times 6 squared. So 6 squared is 36, so that's going to be equal to 36 pi. And 36 pi, the area, multiply that by pi in your calculator. You can do it in your own calculator, but trust me, it's going to be 113.1 inches squared. So that's the area parallel to the base. Now the area perpendicular to the base. Instead of parallel, it's going to be perpendicular. Let's draw our cylinder again. In fact, well, let's get our 4A. So 4A, pause it if you need to get this information again, but the area parallel, cross-section parallel to the base creates a circle. We found the area of the circle. Perpendicular to the base, that's going to be 4B. I said that's going to be 4B. And as we draw our base again, and let me, adjust the notes that I'm looking at. As we draw my poorly drawn cylinder, if you analyze a cross-section, you have our plane. I'm really messing up this drawing, but if you look at that plane that goes through, it's going to create a rectangle for the shape that's perpendicular to the base. And the reason why that's perpendicular to the base is because if you look at the base right here, it's creating a 90-degree angle with the base. But anyway, you have this rectangle where one side of the rectangle is going to be equal to the diameter of the base So that's going to be, if the radius is 6, then the diameter is going to be equal to 12. That's a weird 12, but that's a 12. So this is the diameter of the circle. That's equal to 12. And obviously, when the first problem we saw the radius is 6, so the diameter is just twice the radius. And then the other side of the rectangle is equal to the height of the cylinder. So this right here, the height of the cylinder is also going to be the height of the rectangle. So that's going to be 13 inches. That's going to be equal to 13 inches. And this is 12 inches. So the area of the rectangle is going to be, length times height, or however you want to put it. So it's going to be equal to 12 times 13, 12 times 13. And so area of rectangle, got to know one side by the other side, 12 times 13. So the area is going to be 156 inches squared. All right, that's problem 4. Let's move on to problem 5. And let me erase this problem here. Problem 5. A rectangular solid of unknown density is 6 meters long, 3 meters high, and 7 meters wide. The mass of the solid is 300 grams. Given this information for this homogeneous material, calculate the density. So first of all, we need to start with their density formula. Density is going to be equal to our mass over our volume, or when we write, we can be D is equal to M over V. So what is our mass? Our mass is equal to 300 grams, and our volume, well, we need to calculate our volume. So the rectangular solid has 6 meters, our length is going to be 6, our 3 is going to be equal to our height, and 7 is going to be equal to our width. So our volume is of a rectangular solid is going to be equal to length times width times height. So it's going to be equal to 6 times 7 times 3. And so that will be, as I check my notes, as I've already done this, 126 meters cubed. 126 meters cubed. So that's our volume. This is our mass. So our density is going to be equal to 300 over 126. And this is going to be 300 grams over 126 meters cubed. Get out our calculator. 300 divided by 126 is going to give us a density of 2.38 grams per inches cubed. We can round out to the hundredth place that is acceptable. So our density is going to equal to 2.38 grams per meters cubed. Alrighty then, that is the answer to number 5. Let's move on to number 6. Select, make this bad boy go away. Oh, I should number this number 5. So, bad practice my part, but on yours, make sure you number your problems. That's about being nice and neat. So, as I was saying, number 6. And let me move this up so you can see. Point C is the centroid of triangle PQR with the following segment lengths. QX is equal to 30, QC is equal to 25, PC is equal to 8x minus 4, and CY is equal to x plus 4. Find the perimeter of triangle PQC. So we know that, so there's some things we need to know about the centroid, okay? So let's first draw the triangle. So we have P, R, and Q, and we have X, Y, and Z, and then we're going to have a line between P and Y, Q and Z, and X and R. So the centroid means that it splits the medians into half. So because the centroid is the intersection of the medians of the triangle, so if X, Y, and Z are the medians of the triangle, that means that it's PZ and ZR are going to be equivalent. That means these are equivalent, they're the same length. QY and YR are equivalent, and XQ and XP are equivalent. So this and this are equivalent, this and this are equivalent, this and this are equivalent. Another thing we got to know is that PC is equal to 2CY. So, and I'm sorry, let's call the center C. So PC is equal to 2CY. So if you know, this is just a factor or property of centroids you have to know, that the distance from the vertex to the center compared to from the center to the median is twice as long. All right. So PC is equal to 2CY. So that means that PC, this was, well, and I didn't change the colors, that was PC, that's 8x minus 3, and CY is x plus 4. So PC 8x plus 3 is going to be equal to 2 times x plus 4. Distribute the 2. 8x plus 3 is going to be equal to 2x plus 8. So you got to be able to keep up with these steps here. Let's subtract 2x. Subtract 2x. 6x. And let's also subtract 3 here. Wait, yes. Subtract 3, so that's going to be 6x. I very much apologize. I had a little bit of a kerfuffle with my brain here. But the 2x, you subtract 3, so 6x is going to be equal to, sorry, oh, it's 8x minus 3, that's why. That's why I'm having so much trouble. I wrote 8x, attention to detail, it's 8x plus 3, not 8x minus 3. So, as you see, so make sure you skip ahead at this point. But let's go to 8x minus 3, 8x minus 3. So, when we have 8x minus 3, and oh, another mistake. I keep on making, it's 8x minus 4 if you read the problem. So, essentially for this part, you can just skip ahead. So, I'll have to make a note in class that when you're watching this video, you just skip ahead and ignore this part because this is just embarrassing. I can't even copy down my problems right. I need to get more sleep. So 8x minus 4 is equal to 2x plus 8. So x minus 4 is equal to 2x plus 8. And now you subtract 2x from each side, and also you're going to add, in addition to subtracting 2x, you're going to add 4 to each side. So 2x minus 2x is 0, 8x minus 2x is 6x, negative 4 plus 4 is 0, but then 8 plus 4 is equal to 12, so 6x is equal to 12, and x is equal to 2. Alright, now, we're going to now look at our triangles. So if we look at some of the internal triangles, we have PC, and this is this triangle right here. We have P to C to Q. So P to C to Q, so that triangle PCQ. For triangle PCQ, we're going to have P to C, and we're also going to have Q. So P to C is going to be 13. Because PC is 8x minus 4. I'm sorry. So PC is 8x minus 4. So when we plug in x is equal to 2, it's going to be 8 times 2 minus 4. So that's going to be 16 minus 4. So PC is going to be equal to 12. Then QC is going to be equal to 25. And QP is going to be equal to 60. Well, how do we know that that's going to be equal to 60? Because QX is going to be equal to 30. This is going to be equal to 30 because it's equivalent. And combined, they're going to be equal to 60. So this is equal to 60. This is equal to 12. Now, this is going to be equal to 25 because as far as QC is concerned, it already says right here it's equal to 25. So the perimeter it's going to be 60 plus 25 plus 13 because so the perimeter, right, this side is 60, this side is 25, and this side is 12. So that's equal to 97. I want to just go over how we got the answer one more time because this is probably one of the more confusing problems. So we need the perimeter of the triangle. PQ, that's equal to 60 because that's 30 and 30. That's 30 is given to us. So that's going to be equal to 60. Then we have QC, which is going to be equal to 25, and PC, which is going to be equal to 12. Remember, we're not finding the perimeter of this entire triangle. We're just finding the triangle of PCQ or PQC. So this triangle right here. So we're only finding the perimeter of the red triangle. This red triangle right here, not the whole triangle, just the red one. So let's move on, okay? And I very much apologize for, I guess, making mistakes and pausing it. But one good thing about number sense and math is that you have the ability to catch yourself making your own mistakes and correct them in real time. That actually shows if you can do that, that'll help you catch when you make a mistake and get problems right on the test. Now let's move to number 7. Number 7, a right circular cylinder has a volume of 1,000, height of 8. What is the diameter of the cylinder to the nearest inch? So the cylinder, our cylinder, and this is number 7, has a volume of 1,000. And so that's equal to, that's our volume. And let's look at the volume formula for a cylinder. It's going to be the area of the base times height, or to be more specific, pi r squared times the height. And the height is 8 inches. So 8 is equal to the height. So what we do is we can actually set our formula for the volume of the cylinder to the volume. So pi r squared times 8 is equal to 1,000, because that's the volume. This is the volume formula. So the radius is the only one we don't know, so we'll have to find the radius. We're going to have to find r. So pi r squared times 8 is equal to 1,000. So pi r squared times 8 is equal to 1,000. We need to find r, so we need to isolate the r. So first step, we're going to divide by pi times 8. And we're just going to divide this one by pi times 8 as well. And so that's going to, the 8 is going to cancel out with the 8, and the pi is going to cancel out with the pi, so that's going to give us r squared. So let's figure out what that is real quick. (1,000) divided by 8 times pi. 39.788. So that's going to be equal to sorry, actually let me erase that. So r squared, so we canceled out the 8 and the pi, but we didn't cancel out the r squared. So our r squared is equal to 39.789. Let's round up. And so to find r, we can cancel out the squared by taking the square root. So we take the square root of both sides. And so hitting second, the negative sign, gives the square root of our answer. And so our answer is going to be 6.307. So the radius, so the square root of r squared is r. R is equal to 6.307. So that's the radius, but we need to find the diameter. And so we found the radius, but we need to find the diameter. If you notice something, what's the diameter of the cylinder to the nearest tenth inch? So we need to find the diameter. So the diameter is equal to 2 times the radius. So the diameter is going to be 2 times 6.31. So the diameter is going to be 12.62. All right, let's move on. I'm going to try to move at a faster pace from this point on, but don't worry if it's too fast for you, because you can always pause and go back. But I do want to start moving at a faster pace so we can get through all these problems. So let's move to number 8. In the diagram, sorry, let me move number 8 up for you. In the diagram below, point B is the in-center of triangle FEC, and EBR, CBD, and FB are drawn. If the measure of FEC is 84, measure of ECF is 28, determine this and state the angle of BRC. So I'm just going to start for number 8. I'm going to start drawing it, okay? So we have FRC. We're going to have E, and we're going to have D. This angle right here is 42 degrees. That means this angle right here is also 42 degrees. So sorry, it's not 100% clear. Then we have this angle here. These are angle bisectors. So we know that this is this angle is equivalent to that angle, and we know that looking at this angle, that these angles are also equivalent to each other. Let's draw another triangle that's created here. We have E. We're going to have, and this is B, for E, B, R, as that relates to C. And obviously this is not to scale. This is not a right triangle, but I'm drawing it like this anyway. So R, we have a value there. Then C is going to be equal to 20 ECF. That's going to be equal to 28. And then this angle is going to be equal to 42. And we're going to have our B as well. So the measure of angle ERC is going to be equal to 180 minus 42 minus 28, which is going to be equal to 110. We're going to have corresponding angles for ERC and BRC. So the angle of BRC is going to be equal to 110 degrees. All right. So this one is a little tricky, but if you take your values, ERC is going to be 180, because that's the total number of degrees in an angle, minus 42, right? Minus 28, and this measure right here is 28, and that's just given that ECF as a total, that's going to be 28. All right. Now moving on. Number 9. If DF is equal to 13, what is DE equal to? So number 9 is DF is equal to 13. What is DE equal to? So let's draw our triangle. We have A, G, and C. We're also going to have F and B. And we're going to have, these are going to be congruent, and these are going to be congruent, and we're also going to have point E, and this is going to be congruent, and that's going to be congruent, and we're going to have our value at C here, and these, we're going to have our center D, and from F to D, sorry, my battery's running low. We're going to be, is going to be equal to 3. I'm sorry, 13. Not 3, 13. It's given right there. We need to find DE. So DF is equal to DE, and DF is equal to 13. So DE is equal to 13. All right. Here you just kind of have to see it. You just got to know that the distance from between medians for an incenter, they're congruent. So double check your notes. Just kind of look at visualizing this one. All right, number 10, and then, well, let me get to 11, and then I'm gonna pause so I can charge my computer. Number 10, in rectangle PQRS. Sorry, let me adjust something here. Okay. Rectangle PQRS. PR is 18x minus 24. QS is x plus 146. Find the value of x and the length of each diagonal. So we're going to have P, Q, R, and S. going to have to find the value of x and the length of each diagonal. So PR is going to be 18x minus 24. And then QS is going to be x plus 146. So this is going to be, that's going to be 18x minus 24. And this is going to be x plus 146. I've got to know that a rectangle is a parallelogram. A rectangle is a parallelogram, so opposite sides are going to be congruent, which means that 18x minus 24, we can set that equal to x plus 146. So we can do 17x is equal to 170, and x is equal to 10. So add 24 to each side, subtracted x from each side. 17x is equal to 170, x is equal to 10. Now, PR is going to be equal to 18 times 10, because it's 18x minus 24, so that's going to be equal to 180 minus 24. So that's going to be equal to 156. And QS is going to be equivalent to QS is going to be equivalent to PR, because PR is equivalent to QS because diagonals of parallelograms are congruent to each other. And opposite sides of parallelograms are congruent to each other, and a rectangle is a parallelogram, so therefore PR is congruent to QS. So if PR is equal to 156, then QS is also congruent to 156. Alright. Apologies. So I drew the diagram wrong, but the answer is still correct. So this is actually PR. This is Q and S, but because rectangles have equivalent diagonals, the properties stays the same. So not only are opposite sides of parallelograms congruent, but diagonals of rectangles are congruent. So diagonals of parallelograms bisect each other, but additional cool thing about rectangles, diagonals of rectangles are congruent. So this whole algebra here still checks out. So let me go on to number 11, and then I can stop this video and do the next half of the common assessment. In the diagram, Josh found the centroid P by constructing three medians. He measured CF and found it to be 8 inches. The CP is equal to x. What is the equation that can be used to find x? So here, let's do number 11. Draw our triangle. So A, F, B, D, C, E. We have the centroid here. So we have our three medians. We have center P. So that's a P. So that means the medians cut AC into equal parts, CD and DB into equal parts, and AF and FB into equal parts. And we need to find measure of x, which is the length of PC. So what do we know? We know that CP is x. And what can we use to find x? Well, we know that CF is 8. So CF is equal to 8. And we know that for our centroids, we can put in the equation. CP is equal to 2 times PF. Because with centroids, the distance from the vertex to the center of the triangle and from the center of the triangle to the opposite side of the vertex is a ratio of 2 to 1. That's just something you got to know. So as a corollary to that, CF, which is the whole thing, is going to be equal to CP plus PF, right? CP plus PF is going to be equal to CF. So that means 8 is going to be equal to x plus 1/2 x. So CF is 8, so 8 is going to be equal to x plus 1/2 x, which means that we're going to solve, or it just has write an equation that can be used to solve for x. So that's just the equation. So this is the answer. If you want to solve it, 3/2 x is equal to 8. Divide 8 by 3x. Divide 8 by 3/2. And this means that I'm working late tonight. So that's going to be 8 times 2/3. So if we really wanted to find our value, it would be 16/3. All right. So that's 11. Let me cancel CMS from shutting me down so I can work later into the night at 6:10, and I'll see you. Control. Welcome back, Math 3. So now we're going to start with 12 and I'm going to try to, as efficiently as I can, move through the entire rest of the test. So let's get going. Let me hydrate, do a little Marco Rubio before we get going. Okay, so let's get started. Number 12. For the parallelogram, let me adjust the question here so you can see it. For the parallelogram, if the measure of angle 2 is equal to 5x minus 28, the measure of angle 4 is equal to 3x minus 10, find the measure of angle 3. The diagram is not to scale. So we're going to have parallelograms with angles 3, 4, 2, and 1, and 1. Where the measure of angle 2 is going to be equal to 5x minus 28, and the measure of angle 4 is going to be equal to 3x minus 10. And let's just look at this parallelogram here. So measure of angle 2 and 4, they're opposite angles of a parallelogram. And this is just a property of parallelogram. You have to know opposite angles of parallelograms are congruent. So that means we can put these together and solve for x, then plug x back into the equation to find out the value, and then we know that they're 360 degrees in a parallelogram, and also means that adjacent angles add up to 180 degrees in parallelogram. So solve for x, plug it back in, find the angle, and then solve for angle 3. This is what we need to know to get our answer. So let's start the problem. We can set the 2 and 4 equal to each other. So 5x minus 28 is going to be equal to 3x minus 10. Subtract 3x, subtract 3x, and let me adjust my screen a little bit. 2x minus 28 is going to be equal to negative 10, and so add 28 to each side. 2x is going to be equal to 18, and x is going to be equal to 9. So x is going to be equal to 9, so the measure of angle 2 is going to be 5x minus 28. Let's plug in 9, so 5 times 9 minus 28. 5 times 9 is 45. So you got to know your timetables for that one. So 45 minus 28, that's going to be equal to 17. Check the math on your calculator, see if that's right. So if the measure of angle 2 is going to be 17, then the measure of angle 4 is going to be equal to 17. So same side angles in a parallelogram are supplementary. So pause the video if you need to get the work from right here, because I'm going to erase it. So with parallelograms, the same side angles are supplementary, which means they add up to 180. So same side angles for parallelograms are supplementary. Therefore, angle 2 plus angle 3 is equal to 180. And so that means 17 plus angle 3 is equal to 180. Subtract 17 from each side. And angle 3, measure of angle 3, is equal to 163 degrees. So 163 degrees, that's our answer for number 12. Let's move. What's that bad boy doing over there? Messing up my podcast / screencast. Alright, let's go to number 13. In the diagram below, triangle ABCD is a point on AC, AB is extended to E, and DE is drawn so that triangle ADE is congruent to triangle ABC. If the measure of angle C is equal to 52 and the measure of angle A is equal to 73, what is the measure of angle ABC? So let's draw this out. We're going to have A and B. We're going to have our triangles. C, that measure is 52. This is problem 13. So that's 52 degrees. That is negative 13 degrees. I'm sorry. I'm very sorry. Measure of angle C is 52. Measure of angle A is 73 degrees. What was I thinking? Measure of angle A is 73 degrees. Read the problem, Nick. And then the measure of angle B, we know there's 180 degrees in the triangle. So the measure of angle B is going to be 180 degrees minus 73 minus 52. And put that into your calculator. 180 minus 73 minus 52, that's going to be equal to measure of angle B is going to be equal to 55. Put that in the calculator, verify that's correct. You should be able to do addition, subtraction in the calculator. Furthermore, we have point D right here, and that extends to point E and becomes this triangle as well. So E is equivalent to 52, but what's important is measure of ADE. So measure of ADE is going to be 55, and here's why. I'm sorry. Yes. So measure of ADE is going to be 55. So here's why. So what you do is measure A is 73, measure C is 52, and measure B is going to be 180 minus 73 minus 52, which means the measure of angle B is going to be 55. And angle B corresponds with angle E, okay? So you just have to look at the triangles and know that B is going to correspond with E. So that's why ADE is so angle D is going to correspond with angle B. So D is equal to 55, just like B is equal to 55. Angle E is going to correspond with angle C. So here's the best way that you can look at it. Angle E corresponds with angle C, and angle D corresponds with angle B. So when we found out angle B, that gives us angle D, and we need to find angle D. That's what the question is asking for. So you got to know that angle D corresponds with angle B. Angle B is 55, which is 180 minus 73 minus 52. So ADE is equal to 55 degrees. Apologize, I should have narrated that one better. It's one thing to be able to do the math, one other thing to talk through the math in real time while the pressure's on. All right. Luckily, this isn't for the masses, just for you. Okay. Write this as a two-column proof. Given ABCD is a parallelogram, prove triangle AEB is equal to a triangle CED. So we need to prove that. Let's go through the proofs. Statements, for proofs, let's turn this into a more traditional color. We're going to have our statements, and we're going to have our reasons for our proof. So ABCD is a parallelogram that's given. That's given to us. It's given to us in the problem, so we can just say that's given. AB is going to be congruent to CD because opposite sides of parallelograms are congruent. Opposite sides of parallelograms are congruent. Look at the picture on your question sheet to see that AB is congruent to CD. Additionally, BE is line segment BE is going to be congruent to line segment ED, and AE is going to be congruent to EC, and AE is going to be congruent to EC, and these are line segments because diagonals of parallelograms bisect each other. And so triangle AEB is going to be congruent to triangle CED because of the side triangle theorem. So looking at our parallelogram right here, AEB, this side is congruent to that side, this side is congruent to this side, this side is congruent to that side is congruent to that side. So all the sides of the triangle are the same, so the triangles are congruent. All right, let's move on. 15. The triangle shown below is rotated about the line M. What is the approximate value of the resulting three-dimensional figure? So we have a triangle. It's 6 centimeters by 8 centimeters by 10 centimeters. And when we rotate it about this axis, it's going to become a, see as it rotates, it's going to become a cylinder. All right. So it's going to become a cylinder. So let's take a look at it there, where for our cylinder we have a radius of 6 and a height of 8. So we need to find the volume. So the volume of a cone, I'm sorry, this clearly rotates to a cone. I said cylinder, I meant cone. I visualized a cone. This is a cone. The volume of a cone is going to be 1/3 pi r squared times height. So at this point, you just plug it into your calculator. Volume is going to be equal to 1/3 pi times 6 squared times 8. You put that in your calculator, the volume is going to be equal to 301.59 cubic centimeters. All right, moving on. (16). All right, this one's a little tricky. So we're going to have our solution set. I'm sorry, we're going to have a triangle. We're going to have R, Q, and P, and then you're going to have, right, you're going to have your altitudes. So you're going to have point A right here, and you're going to have 3 lines going through point A. You're going to have B, A, and C. So you have B, you have A, so it's going to go through A, and then you're going to have C. A, B, and C are perpendicular bisectors. What is the value of x plus y plus z? So you need to find x plus y plus z. This value right here, RA, that's 8x plus 16. This value, AQ, is going to be equal to 24. Alright, this value, PA, that's going to be 5y minus 6. I'm just copying the problem here, so we can, but I'm modeling how you can diagram this on your own paper. Alright, this value is 18, this value is 7z plus 4. Alright, let's start with some finding out the things we need to know. 8x plus 16 is going to be equal to 24, so AR is going to be congruent to QR. That's just something you got to know. You got to be able to look at the triangle, know the properties, know that distance from the vertex to center A is equivalent to from the opposite vertex to center A. So RA, QA, they're congruent. So 8x plus 16 is equal to 24. Let's solve for x. Subtract 16. AX is equal to 8 because 24 minus 16 is 8. Divide each side by 8. And that means x is going to be equal to 1. So that's not the answer, but we're going to box that because that's important information. Then 5y minus 6 is going to be equal to 24. Because we also know that for PA, that's also going to be equal to QA. So once again, RA is going to be equivalent to QA, and PA is going to be equal to QA. So 5y minus 6 is equal to 24, add 6 to each side. 5y is going to be equal to 30, add 6 to each side. Divide 30 by 5. and y is going to be equal to 30 divided by 5 is 6. Once again, if you want to prove this, you can use your calculator. So, last part, 7z plus 4 is equal to 18, because these are just two medians. So, sorry, 7z is equal to 14. I subtracted 4 from each side. So, z divided each side by 7 is going to be equal to 2. So x is 1, y is 6, z is 2. So x plus y plus z is going to be 1 plus 6 plus 2. So that's going to be 1 plus 6 is 7 plus 2 is 9. So our answer here is going to be equal to 9. That's x plus y plus z. That's equal to 9. Alright, on to the next one. And this was, of course, number 16. Alright. I think we're in the latter third. Find the coordinates of the centroid. So we're going to have, for 17, we have x, y, z. X is negative 4, 2, y 0, 5, z is 3, negative 1. So x is going to be negative 4, 2. Y is going to be 0, 5. And z is going to be 3, negative 1. Find the coordinates of the centroid. So what we're going to do, you can just find the centroid by adding up the x's divided by 3, adding up the y's divided by 3. So our centroid, that's going to be have coordinates negative 4 plus 0 plus 3 divided by 3, and 2 plus 2 minus 1 plus negative 1, that becomes minus 1 divided by 3. This comes from the properties of a centroid, so make sure you intuitively understand those properties. So that's going to be, combine those together, you're going to get negative 1/3 and 1. That's equal to centroid. That's our answer. That's 17. Let's move on to 18. Alright. The density of copper is 10.5 grams per cubic centimeter. A weight of 1 ounce is equivalent to a mass of about 30.3 grams. What is the side length of a cube-shaped block of copper that has a weight of 6 ounces, right? So first of all, we know that D is equal to M over V. Additionally, we got to know that our density is 10.5 grams. Our mass is going to be 30.6 grams. Weight is 6 ounces. Our volume is question mark. Our side length is question mark. So our density is going to be 10.5 grams per cubic centimeter. So 10.5, that's our density, is going to be equal to our mass, which is going to be 30.3 times 6 over volume. So 10.5. So 10.5 times the volume is equal to 30.3 times 6, which is going to be 181.8. So we did 30.3 times 6 to get 181.8, and I multiplied each side by V, so I get 10.5 V, 181.80. Okay? Now, to get our volume, I divide each side by 10.5. and 181.8. That's going to be 181.8 divided by 10.5. 17.314. So we can just simplify the 17.31. Alright, so our volume, the volume of our shape is going to be 17.31, but this is a cube. Let's make the calculator move somewhere else for a second. So this becomes a cube, so if 17.31 is the volume of the cube, then the side length is quite simple. You just find the cube root. So 17.31 cubic centimeters, that's the volume of the cube. So to find the side length of the cube, you just take the cube root or raise it to the 1/3 power. So 17.31 to the 1/3 is going to be equal to our answer. So we take our answer, raise that to the 1/3 power, and that's going to give us an answer of 2.58, but that's going to round up to 2.59. So our answer is going to be 2.59 centimeters. That's going to be equal to the side length of the cube. It's the side length of the cube. That's 18. As far as 19 is concerned, the perimeter of the rectangle shown is 76 centimeters, is rotated around the line B. Find the volume of the three-dimensional figure formed. So we know that, let's draw this. Let's just draw this bad boy for number 19. If this length is 24, that length is 24, and the total length of all the sides is 76. So 76. Well, let me draw out the algebra for you so you can see. Perimeter is going to be equal to 2 length times 2 width. So 76 is the perimeter, and 2 times our length is going to be 2 times 24. We still need to find 2 times width. So 76 is going to be equal to 48 plus 2 times our width. I need to subtract 48 from each side. So 76 minus 48 is going to be 28. Use your calculator to verify. 28 is going to be equal to 2 width. And divide each side by 2. And 14 is going to be equal to our width. Now, we rotate this. And it's going to create a cylinder. So when we rotate this, have our line, it's going to rotate the rectangle. We're going to have a cylinder with that rectangle still being there in the cylinder, okay? And so the volume of the cylinder is going to be pi r squared times the height, and the radius is going to be 14 and the height is going to be 24. So looking at our rectangle, that as it relates to the base, the radius is 14 and our height is 24. So r is equal to 14 and our height is equal to 24. You just need to visualize that 24 becomes the height of the cylinder and 14 becomes the radius of the cylinder, okay? So the volume of the cylinder becomes pi times 14 squared times height, which is 24, Plug that into your calculator, and you're going to get 14788.05 centimeters cubed. All right. Verify, but that's how you visualize the rotation of a rectangle to create a cylinder. Plug it into the formula for the volume of a cylinder. All right. Then let's do 20 and then 20. 21's a doozy, but let's do 20 and then we can do 21. The manufacturer is shipping a spherical globe, and the globe fits a box shaped like a cube. The globe is touching all sides of the box. The volume of the box is 343 inches cubed. What is the volume of the globe? So here, let's do some algebra first, and then we can draw it. So the volume is equal to 343 inches cubed. And that's the volume of the box. So the volume is also equal to the side length cubed. That's how cubes work. The volume of a cube is equal to side length cubed. So 343 is equal to the side length cubed. So to find the side length, you raise each to the 1/3 power. Raise that to the 1/3 power, and the 1/3, 3 and the 1/3 is going to cancel out to just be s to the first power, or just s. So s is equal to 343 to the 1/3 power. Let's find it out right now. 343 to the 1/3 power. So a side length of the cube, side length of the cube is going to become 7. Now let's draw this thing. Have a cube, and we have a sphere in it. So I don't really know how to draw a sphere, but we have the side length of the cube, that's equal to 7. And so you notice 7 is the side length of the cube. So the diameter is equal to 7. And the volume, I'm sorry. So you got to see that the diameter of the cube is going to be 7, because 7 is the side length of the cube. So the diameter of the sphere is going to be 7. So to find the radius of the cube, oh my god, I'm mixing up my words. But let's just write the volume of a sphere. Volume of a sphere. Got to know this. 4/3 pi r cubed. So we know the diameter is equal to 7 for the cube. You just have to visualize that the entire side length of the cube is going to be equal to 7, which means the radius is going to be equal to 3.5. So the volume of the sphere is going to be equal to 4/3 times pi times our radius, which is going to be 3.5 cubed. All right. So we have 4/3 times pi times 3.5 cubed. So that's going to give us 179.59. So I think I did that correctly, but I'm pretty sure I found the surface area. Surface area is 7. Volume of the sphere is 4/3 pi r cubed, and that the radius is going to be equal to 3.5 because the diameter is going to be equal to diameter is equal to 7. All right. So let's move on to 21, so we can finish this thing. So 21, as I said, is a doozy. All right, let's go to 21. Prove that the vertices A is 2, 2, B is 1, 4, C is 2, 8, and D 1, 10 form a parallelogram using distance, slope, and midpoint. So we have, I'm just going to give a rough sketch. This would be around where B would be. Around where B would be. This would be around where A would be. This would be D. And this would be C, approximately. It's obviously just a rough drawing, okay? So the distance formula is going to be the square root of x squared minus x1 plus y squared minus y1, both in parentheses, okay? So the distance between AB, CD, DB, and CA, we're going to do all of them. So AB and is going to be 2, 2 and 1, 4. So the distance between AB is going to be square root of 1 minus 2 squared plus 4 minus 2 squared. So that's going to be the square root of 1 plus 4, which is going to be equal to the square root of 5. All right. So that's going to be AB. CD, that's 2, 8 and 1, 10. That's going to be, this distance is going to be equal to the square root of 1 minus 2 squared plus 4 minus 10 squared. So it's going to be equal to square root of 36, which is going to be equal to 6. Now, dB, it's going to be 1, 10 and 1, 4. So the distance is going to be equal to the square root of oh man, sorry. So I was asleep at the wheel here. I did, this should be 10 minus 8 squared. Sorry. So that's 1 minus 2 squared plus 10 minus 8 squared. So that's going to be 1 plus 4, which is going to be, so that's going to be the square root of need to get more sleep. So that's going to be the square root of 1 plus 4, which is going to be equal to the square root of 5. Now dB is going to be 1, 10 and 1, 4. It's going to be the square root of 1 minus 1 squared plus 4 minus 10 squared. That's going to be the square root of 0 plus 6 squared. So that's going to be equal to the square root of 36. So our distance is going to be equal to 6. And then CA, that's going to be 2, 8, and 2, 2. So our distance is going to be the square root of 2 minus 2 squared plus 8 minus 2 squared. So that's going to be equal to square root of 36, which is going to be equal to 6. So if we notice here, distance for line segment CA and DB, both equal to 6. And for AB and CD, both equal to square root of 5. This is equal to the square root of 5. And this is equal to square root of 5. And this is going to be equal to 6. And this is going to be equal to 6. So opposite sides are congruent. So this proves with the distance formula that these are congruent. So that's one part of 21. Let's do the other part of 21. So opposite sides are congruent. So therefore, ABCD is a parallelogram. So that's using the distance formula to prove it. Let's use the next one. Oh man. Alright. Alright, next part is going to be just the midpoint formula. So let's do, the next one is going to be 21 using the midpoint formula. So AB is going to be 2, 2. CD is going to be, AB 2, 2 and 1, 4. CD 2, 8 and 1, 10. DB is going to be 1, 10 and 1, 4. And then AC is going to be 2, 2 and 2, 8. So let's find the midpoint for each one. So the midpoint here, that's just going to be equal to 4 minus 2, over 1 minus 2, which is going to be equal to, M is slope, I'm sorry. I said, I don't know what I'm thinking, but I did M, but M is sign for slope. So you find the slopes. So 4 minus 2 over 1 minus 2, it's going to be 2 over negative 1, which is going to be equal to negative 2. Then, here you're going to have 10 minus 8 over 1 minus 2. Which is going to be equal to 2 over negative 1, which is going to be equal to negative 2. So AB and CD have the same slope, so opposite sides are parallel, so this is looking good. For this, 4 minus 10 over 1 minus 1, find the slope, that's going to be 6 over 0, so that's undefined. That's an undefined vertical line. And then 8 minus 2 over 2 minus 2 is going to be equal to 6 over 0. And that's also an undefined vertical line. So undefined vertical lines are parallel with each other. So these have the same slope. Opposite sides have the same slope. So we have, this proves that they're parallel. Opposite sides are parallel. So we're good to go. Last part is going to be using midpoint. And then we can be done with this video. So the midpoint formula is going to be midpoint. It's going to be x1 plus x2 over 2, y1 plus y2 over 2. So I'm just gonna do the math here, okay? Midpoint is gonna be equal to 2 plus 1 over 2, comma 8 plus 4 over 2, which is gonna be equal to 3/2, 6. So that's for CB. That's for CB. For DA, you're going to have our midpoint is going to be 1 plus 2 over 2 and 10 plus 2 over 2, which is also going to be equal to 3/2, 6. So these are the same. This proves that for a parallelogram, diagonals bisect each other. Diagonals bisect each other, okay? So that's the video. Have a good night, / day, / whenever you watch this. How's it going, my pre-calculus class? So, essentially today I'm making a tutorial video as a solution set to your study guide. So you need to have your study guide out in front of you, and then I'm going to be going through the problems one by one. So let's do it. 1A. You need to describe the domain of each function using set and interval notation. So you really need to have your study guide out in front of you in order for this to work effectively. So f of x is equal to the square root of 2x minus 5. And so, sorry, I need to have mine out in front of me as well. So let's make sure I'm looking at this right. So in order to find the domain of this function, one rule about finding the domain is you cannot take the square root of a negative number. So you need to make sure that 2x minus 5 stays at least equal, greater than or equal to 0. So the product inside of the square root, 2x minus 5, must be greater than or equal to 0. Add 5 to each side. 2x must be greater than or equal to 5. Divide each side by 2. X must be greater than or equal to 5/2, 2.5. Let's put that in interval notation first. So if x has to be greater than or equal to 2.5, our domain is going to be from 2.5 to infinity. Using set notation, we're going to have brackets x such that x is greater than or equal to 2.5, close brackets. So that's 1A, so not 19, but 1A for our study guide. Let's go on to 1B. 1B. F of x is going to be equal to 1 over 3x plus 1. So you cannot divide by 0 in this case. So the denominator cannot be equal to 0, which means that 3x plus 1 cannot be equal to 0. Therefore, let's continue the algebra here. 3x cannot be equal to negative 1, so I subtracted 1 from each side. Divide each side by 3. And x cannot be equal to negative 1/3. Alright? So that's what x cannot be equal to for the domain. Let's put that into interval and set notation. Interval notation. So x can be all values except for 1/3. So you're going to have, you can be negative infinity to negative 1/3, not inclusive. So you're going to have an intersection, so and negative 1/3 to infinity. I'm gonna do a quick Google search actually, because I want to make sure I use the correct notation here. So, Facebook out. That's not a union and intersection. So really modeling, going through this in real time. So if you look for union and intersection, so union is right. Not a good site. So union is A and B. Okay, so let's change that. So it'd be, sorry, I just had a brief brain fart about what's and or. So this negative 1 infinity and 1/3 and negative 1/3 to infinity. So okay, so 1b. I apologize for that ill preparation for me. I was just kind of going through this, and I had a temporary lapse on what was union and what was intersection. You'll be unforgiven in college for that. 1c. You're going to have f of x is going to be equal to the square root of 3x plus 6 over x minus 4. So first of all, 3x plus 6 must be greater than or equal to 0. 3x must be greater than or equal to negative 6. X must be greater than or equal to negative 2. Now, also, x minus 4 cannot be equal to 0, so x cannot be equal to 4. So we have a situation where x must be greater than or equal to negative 2, and x cannot be equal to 4. So using interval notation, it has to be greater than or equal to negative 2. So you can go from negative 2 to negative 4 not inclusive, and, so that's a union for and, you can go from 4 not inclusive to infinity. As far as set notation, we can have x such that x is greater than or equal to negative 2, and that x is not equal to 4. Close the brackets. Alright, that's 1c. For the 1d, at any point you can pause this, ask me questions. I should be in the classroom while we're doing this, so you can ask me questions as well. Brushes. Let's go. 1d. F of x equal to 2 times x minus 1 over x. 2 times square root of x minus 1 over x. X minus 1 cannot be greater than or equal to 0. So x has to be greater than or equal to 1. Wait. Yeah, x minus 1 has to be greater than or equal to 0. Add 1 to each side. X has to be greater than or equal to 1, because if x is going to be anything less than 1, it would be negative. Okay, and then x cannot be equal to 0. So using interval notation, x cannot be equal to 0, and x has to be greater than equal to 1. So if you look at our number line, we have 0. We can't be equal to 0, and it must be greater than or equal to 1. So actually, for domain, the zero doesn't really affect things. Zero interval notation, it's just from brackets 1 to infinity, and then for set notation, x such that x is greater than or equal to 1. X is not equal to 0 is inherent in x is greater than or equal to 1. All right. Supreme Pizza blind taste test. All right. I'm still a kid. Okay, let's go to 2. Specifically 2a, we're going to describe the range of each function using interval notation. So this one is going to be easiest to plot our points. So the first one is going to be 6 minus x minus 4 squared. Oh, look at that window. That window is messed up. X min negative 10. X max 10. Y min negative 10. Y max 10. Graph that jaunt. The range is the set of all y values. So you've noticed something. The highest y value is 6, and then everything else is below that and goes to infinity. So because our highest y value is 6, and 6 is actually going to be the y value of the vertex for this parabola. We know that the range is going to be 6, anything that's below 6. So using interval notation, the range of this function goes from negative infinity to 6. Range, remember, is a set of all y values. So range is the set of all values on the y-axis. Additionally, you can know whether the formula, the parabola is downward slopes, opens down, based on the fact that you have negative x minus 4 squared, and then you know that the coordinate of its vertex, the y value of its vertex is 6. So you can solve it that way as well. All right, moving on. All right, I'm going to start moving at a faster rate here. 2 times the absolute value of x plus 1 minus 7. So 2 times the absolute value of x plus 1 minus 7. Here, our lowest y value is negative 7, and it goes up into infinity. So our range for 2b, looking at the calculator, it's just going to be from negative 7 inclusive to infinity. So lowest value is negative 7, highest value is infinity. Look at the calculator. You can look at the tables if you want to. Right? Lowest value is 7. Doesn't get I'm sorry, lowest value is negative 7. I'm sorry. So going back to the graph. So sorry, if I wrote negative 7 to infinity, that was wrong, but it's negative 7 to infinity. All right. So I forget if I wrote 7 or negative 7, but that's That's going to be our range of f of x. All right, and that was 2b. Select, make that go away. 3b is going to be f of x is going to be the natural log of x plus 5. I'll make sure we have a graphical understanding of this. So let's do the ln of x plus 5. Notice we just have the parent function that's shifted up 5, and as we go to our table here, all these negative values are giving us errors. As we get to when we look at any value lower than 1, it gives us 5. Oh, this is glitching out. Okay. Hooey, that's slow response time. Anyways, the highest y value is 5. You can see it from the graph. So the highest y value is derived, so our range is going to be 5 inclusive to infinity. And that was 2b, I'm sorry, not 3b. So that last one was 2b, then we can have 2d, we're going to have 3 to the x plus 2, so we're going to have 3, so we're going to have an exponential here, 3 to the x plus 2. Let's look at the range of this bad boy. So if you notice for the range here, we're going to have a horizontal asymptote at y is equal to 2. Okay, we're not gonna touch 2 because 3 to the x, even as x becomes a super small negative number, or I said super large negative number, such as negative 1 billion. 3 is going to become 3 to the negative 1 billion is going to become 1 over 3 to, sorry, the 100,000. Sorry, I'm just saying a really large number. That's going to become almost 0, but not quite. So our range is going to be 2 not inclusive to infinity. Okay? Because we start, have an asymptote at 2, don't quite touch it, and we go up to infinity. Describe the increasing intervals for the function. So we need for if f of x, this is for 3 by the way, is equal to x plus 3 squared minus 4, then we need to describe the increase and decreasing of intervals. So you have a calculator, let's use it. X plus 3. A calculator faux pas on Mr. Law's part. X plus 3 squared minus 4. Graph that function. Alright, check this out. We have our parabola, and notice the vertex of this parabola is going to be negative 3, negative 4. So the parabola vertex we're going to get to parabola vertexes and conic sections by the vertex. By the way, is going to be -3, -4. In fact, because our vertex is originally going to be at 0, 0, and it shifts left 3, down 4. So function transformation thing. Notice to the left of the vertex, the parabola is decreasing, which means it has a negative slope. And then past the vertex, it has a positive slope, which is increasing. Remember, you can do the dance to figure out whether something's positive, negative, 0, undefined. Positive, negative, 0, undefined. So on the interval from -infinity to -3, not inclusive because it's going to be decreasing. And from the interval from -3 to positive infinity, it's going to be increasing. And at -3, it's going to be neither increasing nor decreasing. So, in fact, this is modeled by physics. When you throw a ball up in the air, you throw it up with force, and then it slows down, and slows down, and slows down. And when the ball hits the zenith of you, when you throw it up, it actually stops for that time that's at that zenith. Its speed is 0, and then it starts going down at the rate of gravity. So that's just a fun fact as we're doing our math study guide. Let's go to problem number 4. I describe the end behavior of each function using limit notation. So the best way to do this, in my opinion, is just graphing it. You're going to have -3x squared plus 2x. -3x squared plus 2x. Okay? And then we're going to graph the function. We could do this end behavior algebraically by putting in really big, really large positive and really large negative numbers for x. But it's much more efficient, and time is a factor on your common assessments to do this graphically. So if you notice, we have a function like this, and as x approaches -infinity, y approaches -infinity. And as x approaches positive infinity, y approaches negative infinity. So we're going to write that in limit notation. The limit as x approaches -infinity of f of x is equal to -infinity. And this is also for a. And the limit as x approaches infinity of f of x is going to be equal to -infinity as well. So here, that's x approaches -infinity, y approaches -infinity, x approaches infinity, and y approaches -infinity. So that's the gist of how you can do end behavior for limits to infinity. All right. Next problem. F of x is equal to x cubed minus 2x. So you have x cubed minus 2x. I apologize. So we have an odd function. So also in my lesson on end behavior for polynomial end behavior, we talk about end behavior for even and odd functions. But regardless, we have whatever function, our end behavior is like this. I'm just write it down, visualize it for yourself, pause it, ask me, send me questions if you need refresher. But the limit as x approaches negative infinity of f of x is going to be equal to negative infinity. So as x approaches negative infinity, f of x approaches negative infinity, and then the limit as x approaches infinity of f of x is going to be equal to infinity. So as x approaches negative infinity, f of x approaches negative infinity. As x approaches infinity, f of x approaches infinity. You can do this algebraically as well. You can test that out for yourself, though. And that last problem was 4b. 4c. F of x is equal to 85 over 1 plus e to the x. So let's put that into your calculator. +1 plus 3e to the x. Okay, I graphed that wrong. I know how. Okay, I graphed that wrong. I'm not sure how I graphed it wrong, but I'm going to graph this from memory because I know what the graph of this looks like. All right, this is the y value is going to be equal to 85. And when x is very high negative values, it's going to be approaching a horizontal asymptote at 85. And then as you get closer, you kind of have this behavior. And then you're going to approach 0 as x becomes large numbers. So you can have horizontal asymptotes at 85 and 0. So the end behavior is as the limit as x approaches negative infinity of f of x is equal to 85, and the limit as x approaches positive infinity of f of x is equal to 0. And I'm going to see if I can put this into the calculator the right way, because that's just embarrassing that a math teacher doesn't know how to calculate things. So 1 plus 3, maybe I can be more specific here, times e to the x. Let's when we change the window here. So obviously you can skip this part, but just wanted to do it for the fam. Yep, so at 85, then it goes down then it goes down to 0. You can barely see the blue on it, but that's what it's like. Okay, you have to adjust the window for later. For C, for E, f of x is equal to 2 times 0.75 to the x. So two times 0.75 to the x if you can, I can change the window, but you could have seen it from there, but essentially we have our graph, and we have a horizontal asymptote at 0, and then it approaches kind of infinity. So the limit as x approaches negative infinity of f of x is equal to infinity, and then the limit as x approaches infinity of f of x is equal to 0. That's because as x gets really large, approaches a horizontal asymptote of 0, and as x becomes really large, an infinite number, it goes up into forever. So A, B, C, E. So that probably should have been labeled A, B, C, D, but that is water under the bridge and water over the dam. Number 5. Show algebraically and graphically whether each function is odd, even, or neither. So let's do 5a. F of x is equal to 3 over x cubed. So even f of negative x is equal to f of x. Odd f of negative x is equal to negative f of x. So let's find f of negative x here. So that's going to be 3 over negative x cubed, which is going to be equal to 3 over negative x to the 3. So that's actually going to be equal to negative f of x, which would also be equal to negative 3 over x cubed. So this function is odd. Let's look at the function here. Going to have 3 divided by, I should have done alpha y, but whatever, x cubed, and you can look at that odd symmetry. There's some odd symmetry right there. I reflected about the origin. That means it's y. It's odd. So graphically, that means it's reflected about the origin. A simple way to do this is just to plug in 1 and negative 1. You get the same answer. It's even. If you get the same answer but they're opposite signs, so positive and negative, then it's odd. If it's completely different answers, then it's neither. So 5 B. f of x is equal to the absolute value of x plus 6 over 2. So we look at f of negative x. That's going to be equal to the absolute value of negative x plus 6 over 2, which is going to be equal to the absolute value of x plus 6 over 2. They're equal to the same thing. So that's equal to f of x. So this function is even. Let's look at that nice even symmetry proving on the graph, where it's going to be reflected across the y-axis. We're going to go to math, number, absolute value, x, plus 6. Ooh, I made a mistake. Should have done alpha y. Making mistakes, and time is of the essence for you, because I do not want to waste your... Oh my god. Absolute value of x plus 6 over 2, graph that. Absolute value function, you have that reflection across the y-axis, so it's even. All right. Changing the size of my paper. Describe how each function has been transformed from f of x to g of x. So you're going to have f of x as it transforms to g of x is going to be 3 times f of x minus 6. So here this 3 is completely outside of our function. So because it's completely outside, that means it's going to be vertical. And vertical means it's changed by the way you think you are, which means it's going to be a vertical stretch by a factor of 3. And here we have x minus 6, x completely by itself. So if x minus 6, that's going to be right 6. That's from your function transformation rules. So that's going to be 6a, vertical stretch of 3, right 6. Those are the transformations. Let's go on to 6b. Let's go on to 6b. There we go. 6b. As f of x transforms to g of x, you're going to get equal to negative f of 2x minus 6. First of all, we need to factor out that x, so that's going to be negative f. Let's do negative 1f, because that's going to make something apparent here. Factor out the 2 of x minus 3. So notice that 2 is inside the... It's manipulating the x minus 3, but it's inside our parent function. So that 2 is going to be horizontal. And horizontal does the opposite of what you think it's going to do. So even though that you have a factor of 2, that's going to be a horizontal shrink. By factor of 1 over the coefficient. By a factor of 1/2. We've completely isolated the x. So now that's going to be x minus 3. So that's going to be right 3. Minus 3, that's going to be right 3. Now we have that negative 1. Notice the coefficient is 1, so there's actually no vertical stretch or shrink here. because 1 keeps it the way it is. Now we have this negative sign here. That negative completely outside the function. That's going to be a reflection across the x-axis. X-axis reflection. Alright, so we have 3 transformations are an x-axis, a reflection across the x-axis, a horizontal shrink by a factor of 1/2, and going right 3. Alright, 6b. As f of x, I just did 6b. I need to get more sleep. 6c. As f of x, so if f of x is equal to x squared, that's the parent function, so we have a quadratic parent function. G of x is going to be equal to 2/3 times x minus 6 squared plus 1. So I want you to know something. For a coefficient 2/3, it is not affecting that plus 1 right there. It's only affecting the internal part of the parent function, the x minus 6 squared. So because it's not completely outside of g of x, that 2/3 is going to be a horizontal dilation instead of a vertical dilation. If that 2/3 was a vertical dilation, it would be affecting the entire function, including that plus 1. So anyways, horizontal does the opposite what you think. This is going to be a horizontal stretch by a factor of 3/2. So with horizontal, you find the reciprocal of whatever the fraction is by a factor of 3/2. Then you have x minus 1 squared. So that's going to be x minus 1. That's x minus 6 squared. X minus 6, so that's going to be right 6. Minus points for me for bad penmanship, and that's going to be up 1. So you have a shift up 1, a shift right 6, and the horizontal stretch by a factor of 3/2. Uh, 6D, not 60, 6D. If f of x is x squared, g of x is going to be equal to, this is going to be, let me give you more space because this is the dooziest of the doozies out of our transformation problems. G of x is equal to negative 5x plus 3 squared minus 8. Okay? So first of all, we need to factor out the x. That's going to be negative. I have to factor out a 5 to get the x by itself. X plus 3/5 squared minus 8. I want you to know something. That negative coefficient over here only affects the internal part of the function and not the negative 8. So once again, that becomes that's horizontal, not vertical. Okay? But let's look at the transformations here. That 5 is also only affecting the core part of the function and not the negative 8. So it's also horizontal. That's going to be a vertical shrink. I just said horizontal, so why was I writing vertical or saying vertical? Probably because I'm losing my mind. We have a horizontal shrink by a factor of 1/5. We're shifting left by 3/5. We're going down 8. And because this negative sign is only affecting the core part of the function and not the minus 8, it's only part of the function, that's going to be a reflection across the y-axis. It's going to be reflection across the y-axis. All right, so that's all our transformation problems. Given R sub 7, so R of x is square root of x. Q of x is going to be equal to 3x minus 6. So we're going to have R, so first of all, 7a is going to be R of Q of 3 minus Q of R of 5. So let's start plugging this in at the beginning. Q of 3. So it's going to be 3 times 3 minus 6. And that's going to be all a term in R. So that's going to be, we're taking the square root of that. So we're going to take the square root of that. So I'm just going to raise that to the 1/2 power. Same thing as taking the square root, raising it to the 1/2 power. Something you got to know. Minus R of 5. So that's going to be the square root of 5. But we're taking Q of it. So that's going to be 3 times square root of 5 minus 6. So this is going to be simplified to 9 minus 6 to the 1/2, which is going to be equal to 3 to the 1/2 power. And this is going to be minus 3 times square root of 5 minus 6. Just pull this into your calculator. No reason to, we have our algebra correct, no reason to make a math mistake here. It's 3 to the 1/2 power. Same thing as taking the square root of 3. 3 to the 1/2 power minus 3 times the square root of 5. What am I doing here? Square root of 5 minus 6. Plugged it in. This gives us about 10.97. So that's equal to about negative 10.98. So essentially, you're just plugging the values into each other. All right. R of Q of x in its domain. So B is going to be R of Q of x, and you're also going to know the domain. So R of Q of x is going to be okay, so it's going to be the square root of x but the square root is going to be q of x. So that's going to be the square root of 3x minus 6. So that's equal to r of q of x. And to find the domain, we know that you can't take the square root of a negative number. So 3x minus 6 has to be greater than or equal to 0. So 3x has to be greater than or equal to negative 6. Divide each side by 3. X has to be greater than or equal to negative 2. And so our domain in interval notation has to be greater than or equal to negative 2. So we can be from negative 2 to infinity. And then our set notation for domain is going to be x such that x is greater than or equal to negative 2. Right? So that's our composition. That's compositions for the practice test. 8, 9, and 10. So we have 3 more problems, and then I can get out of your, or you can. You're probably sick of me, so I can get out of your face. 8. Given that f of x is going to be equal to 2x plus 4, and the f of x is going to be equal to 3x minus 5, find the inverse and determine whether it's 1 to 1. So let's find the inverse. So first of all, f of x becomes y, and then you switch the x's and the y's. So x is equal to 2y plus 4 over 3y minus 5. Then you multiply each side by 3y minus 5. So x times 3y minus 5 is equal to 2y plus 4. And now you can distribute the x. So 3xy. And here I'm going to do something here. I'm going to subtract 2y from each side, minus 2y, and then add 5 to each side is equal to 5 plus 4. Alright? So now I have that's going to simplify to 9, but first I'm going to factor out a y. So y times 3x minus 2 is going to be equal to 9. So bring that up. Y is equal to 9 over 3x minus 2. Then that's it. That's the inverse. Determining whether it's 1 to 1. The best way to determine whether a function is 1 to 1 is know that each y output has one and only one corresponding x input. But I like to solve this using the horizontal line test. So we have 9 in our numerator, and f of x. We have to determine whether f of x is 1 to 1. We know that f of x is 1 to 1 because our inverse is a function. If f of x was not 1 to 1, our inverse would not be a function. But just to show, to be extra careful, our numerator is 2x plus 4, and our denominator is 3x minus 5. We're going to graph that. Hey, what do you know? The function passes the horizontal line test. There's no point where a horizontal line could go through the function and touch at multiple points. Now, it may not look like that because we're approaching asymptotes, but really, x at a specific value would only touch the function at once. If you had a horizontal line, y is equal to something, it would only touch the function at one specific point. So it passes the horizontal line test. 9, the penultimate question in this video and in your study guide. Find the value of f of 2 minus 4f of 3 plus f of 7 of 2 given that f of x is equal to negative x plus 4, 2/3 x minus 1, and 2. This is if x is greater than or equal to 0. If 0 is less than x, and x is less than or equal to 5. And this is for when x is greater than 5. So let's find f of 2. F of 2, here 2 is in between 0 and 5. So f of 2 is going to use the second function because 2 is in between 0 and 5. So that's 2 falls in that category. So let's plug it in. F of 2, that's going to be equal to 2/3, plug in the 2, times 2 minus 1. It's going to be 4/3 minus 1. So it's going to be equal to 4/3 minus 1, which is going to be equal to 1/3. Do the math on that, check me. I'm pretty sure I'm right on that one though. So f of 2 is going to be equal to 1/3. Now we're going to do we're going to do negative 4. So we'd start with negative 4. Negative 4 times f of negative 3. So negative 3 is actually going to be less than 0. So that's going to do negative 3 here, that's going to be less than 0. So we're going to be using this function. So let's evaluate negative 4. Let's first evaluate f of negative 3. That's going to be negative 4 times negative 3 plus 4. That's going to be negative 4 times positive 3 plus 4, which is going to be negative 4 times 7, which is going to be negative 28. And that's going to be negative 4 f of negative 3. So the answer here, f of this whole thing is going to be negative 28. And then we're going to have f of 7 over 2. So f of 7 over 2, well, f of 7, that's just going to be equal to 2 when x is greater than 5. So if x is equal to 7, f of x is going to be equal to 2. So here, 7 is greater than 5, and any x value that's greater than 5, your f of x value is going to be equal to 2. So f of 7 over 2, that's going to be equal to 2 over 2, which is going to be equal to 1. So when we add up our our orange plus our red plus our blue values, we are going to get sorry, 1/3 minus 28 plus 1. Alright, so that's going to be essentially, simplify that to negative 28 plus 4/3. So as I do the math in my head, because I'm stubborn like that, that's going to be negative 27 plus 1/3. So that's going to be negative 27 plus 1/3 is going to be negative 26 and 2/3. Let's use that as a mixed number. Anyways, add them together. If it's multiple choice, just make sure that your answer is equivalent to whatever the correct answer is when you do your work. but negative 26 and 2/3. That's the answer. That's what I'm boxing. Hopefully I did that one right. If not, that would be embarrassing. Determine the 10. Last problem. You can get rid of me. Determine a value that will make f of x continuous. If so, f of x is going to be equal to negative a of x minus 7 if x is greater than or equal to 4, and then it's going to be equal to 6x plus 2 if x is less than or equal to 4 and if x is greater than 4. So you're evaluating this function when x is equal to 4, because when x equals 4, that's going to make it continuous. So negative a times 4 minus 7 is equal to 6 times 4 plus 2a. So let's combine like terms here and simplify. So negative 4a minus 7 is equal to 24 plus 2a. Add 4a to each side and subtract 24 from each side. You're going to get negative 31 is equal to 6a, which means that a is going to be equal to negative 31/6. That's an acceptable answer to me. That's a good value for a. That makes the function continuous.